In Module 6, we're going to explore data with code. Note in the previous module, we explored data without code or used a BI tool. In this module, we'll actually leverage a coding or programming language called Python. So Python is a very popular language for data science and data analytics. It was actually developed in the late 1980s and was first released in 1991. It was developed by Guido van Rossum. So Van Rossum actually created Python as a successor to ABC with hope that it'd be more intuitive and versatile. The language's name actually came from or was inspired by Monty Python, and that sort of reflects the creator's love for humor and the language's fun and approachable design philosophy. So in fact, it is widely used. In fact, a lot of major applications that probably some of you use were written in Python, including Instagram. So we're going to use it for data analysis, and the way that we're going to use it is actually through Google Colab. So Google Colab is basically a cloud-based Jupyter notebook or Python Jupyter notebook, and it requires no setup to use. All you need is a web browser, and you actually get free access to computing resources, including GPUs and TPUs. So Colab is actually well suited for machine learning, data science, and also education or learning how to use or apply Python. So if you clicked on that link, there's actually a kind of starter notebook or intro notebook, and we'll pull up our own as part of this module. And so largely in data analysis projects, you'll mostly be working with what are called data frames. So data frames are a component of this library package called Pandas. So Pandas basically allows us to analyze structured data. So you can think of the very similar to a spreadsheet where there's rows and columns. This is how Python saves and stores that data set, or what we refer to as a data frame. So there's a lot of different functions that you can use in Pandas. Again, this is a widely used library to analyze structured data. So there's a link also there for a cheat sheet that has a number of useful functions. But how we're going to start using it is basically to profile data. So data profiling, you can see the definition there by IBM. It's the process of reviewing and cleansing data to better understand how it's structured and to maintain data quality standards within an organization. The main purpose is to gain insight into the quality of the data by using methods to review and summarize it, and then also evaluating its condition. It's typically performed by data engineers who use a range of business rules and analytical algorithms. Well, I would say that it's not limited to just data engineers, right? So a data scientist, data analyst could get a lot of useful insights from profiling data or understanding the quality of the data, and also any initial relationships, any initial patterns that they might find. So what you can do is actually load data directly into BigQuery. I have my data preloaded, which allowed us to use Google Connected Sheets. And actually, BigQuery allows for a lot of different data types. So you can see the list there. In fact, there's documentation on how to load data, but even common file types like comment separated or CSV would load fairly easily into BigQuery. But what we'll actually do in our profiling exercise is we'll actually pull the data directly from the web. So that's another capability that you'll see in our data profiling. So we'll actually pull the data directly from the web. In that case, is directly from Kaggle or that source of the data. But within BigQuery, I noted that you can actually load a lot of different formats. In fact, you can actually directly connect to various software as well. So if your organization uses a bunch of different software systems, there's likely the ability to connect somehow directly to that software system, in which case you're getting more live data or sort of a live feed that's being loaded into BigQuery. And what BigQuery also has is a sort of similar capability in terms of profiling, and that's through what's called Dataplex. So Dataplex actually allows you to do a lot of data management, but also profile and also investigate the quality of data as well. So if we go back into this data set that we've been reviewing, right? We looked at it with no code. So now we'll actually use code to understand that data, including the quality and any initial patterns or any initial insights that we can get from the profile report. And really the benefits of this is in the pre-analysis phase, right? In the pre-analysis phase. So before we do our formal hypothesis testing, before we do our statistical test or predictive modeling, it's helpful to understand the quality of data, any initial patterns or relationships. So you can kind of see there the data quality. You might also identify outliers. Also looks at the sort of accuracy of the data and looking at the formats and distributions. Also helps us with understanding, right? So any relationships, distributions, key statistics like the average, the median, also any trends or patterns, especially if we have time series data, right? The trends over time. Any anomalies, right? So any unexpected values, formatting issues, invalid entries. Do we need to deal with any inconsistencies, or do we need to standardize the data in some way? Also helps with data governance and compliance. Also optimizes the data processing storage, right? So if we have redundant or irrelevant data or sort of duplicate rows or columns, we might be able to sort of filter that out or sort of parse those out. So it makes things a little more efficient for us. And then finally, in terms of understanding the data itself, including what format we have it in and what structure, right? Is it ready for analysis, or do we need to do some things to it or some adjustments, make some adjustments to that data before analysis, and that would help us before we do our hypothesis testing and formal modeling as well. So let's get into our notebook. So this is the end of the slide portion, but if I open up our notebook here, you can see that I actually pre-installed a package. This is just giving a list of packages here. So I pre-installed this package, Y-Data Profiling, right? That's going to allow us to do our data profiling. So if I scroll down here, I'm going to import Pandas and also Y-Data Profiling. And then I'm going to import our data directly from Kaggle, right? This is our data set. Just to note again that previously we accessed the data through Google BigQuery. And you can see, I'm just checking to see that it's in there. In fact, it is. And you'll be able to see that if I go here to the left, and you can actually load data in directly here. So if I had this stored locally, I could drag this over, drag a file over in this area, and it would load directly. But we're actually loading it directly from the web. So you can see that I'm just pulling that data set in. DF, data frame, right? So that's what I'm calling my data frame, but you could call this whatever you want, right? I could have called it Shark Tank DF. So you can see that's my records, right? I have my rows, my columns, and I have a pretty good view of that data. So let's go ahead and generate our profile and save that as an HTML. But you could also display it within the notebook as well, directly within the notebook. So it'll take a little bit of time to run. So you can see though that what we're going to get is a very detailed report on our data, and it's going to help us understand the quality, understand any relationships, also importantly, understand the data types or how they're being perceived. As I mentioned, any analysis that we do, it's really going to depend on, in part, the data type, right? Is it numeric? Is it categorical? So that's some of the things that we're going to get from this. So while it's running, what I'll actually do is I'll actually show you within BigQuery. I actually have a project set up, so you can see that project name there. If I see, I can pull up sort of different projects as well. But what I want to do is go to run a query in BigQuery, and you then see this project, and in fact, there's a data set, Shark Tank data set, and then within that data set, there's a table, right? There's a table. So what I could actually go to is I could actually go to data profile, and I would actually be able to produce a very similar report. And this was actually already populated as well, but you can see it kind of gives me some interesting summaries on all of my columns, right? So it shows me, and this is I guess sorted by column name alphabetically, but it shows me the different data types, also some statistics, top 10 values. If I kind of go a little bit further down, yeah, it's a pretty similar summary for each field. And yeah, so it has our full variable list, and that kind of gives us some detail or some insights by looking at this report. But what would also be helpful is to see even more, and that's what Python's going to allow us to do, right? The profiling report. But this is the basic structure. In BigQuery, you have the dataset name and then also the tables within that dataset name. So what we can go back to is, okay, we're about done with the profile report. And you can actually see there that it actually loaded. So I could actually download this if I want to, and then open it up in a web browser. It actually is in HTML format. But what we can do is we can actually display it directly in the notebook as well. So I'm going to go ahead and do that. Yeah, so if I scroll down here, you can see there's a full report on my data. So I can see the variables, number of data points or records, missing cells, missing cell percentage. Are there any duplicates? Also the variable types, right? So numeric, text, data frame, or sorry, datetime, categorical, and then Boolean. And I see a very similar view to what I saw in BigQuery for each individual variables. And you can see well, season number isn't that helpful, but maybe if we look at let's go down here. Well, this is sort of this is a date, right? So I can see kind of the date range, So that would be helpful. If I have time series data, if we keep scrolling here, yeah, so with categorical variables, I can see the breakdown in terms of the categories for industry, right? And if you pop into more details for categorical, you get even more information, right? So you can see the the categories. So top category is food and beverage. There's also words within that, characters, but you can see also that, let's go to numeric fields. Yeah, so a quantitative variable, right? US viewership. And you can see kind of the viewership, the distribution of the viewership. So that helps us understand, is our data normally distributed? What's the distribution of those data points, or in this case, these pitches? It also gives us an indicator of correlation as well. So in fact, this US viewership has a correlation with pitch number and also season number, which is actually pretty interesting. And what we'll see, yeah, original ask amount, right? So there's actually some outliers you can kind of see in the tail for the original ask amount. But you obviously can see all the summary stats here. Again, if I go into more details, I can see more detailed statistics, including the 25th percentile, 50th, and then 75th, and also the 5th and 95th. The interquartile range, which is just the difference between Q3 and Q1. Also, the standard deviation is useful as well. So a lot of good insights that I can get from just this single report. So got deal, obviously we know this number, that 844 of all the deals, or sorry, all of the pitches received a deal. And what's nice about this is I actually access the data directly from the web. So if this data gets updated at all, my analysis would get updated. So there actually may even be some discrepancies from the static example that you saw earlier when I used connected sheets and Tableau, right? That was a one-time download and not directly connected to the web version of this data source. So if I keep going, yeah, so again, there's some anomalies with the total deal amount out here. Or sorry, outliers, not necessarily anomalies, but outliers are sort of very large deals that were made, right? And if we go further down here, I'm just going to click down to interactions. So, lost web. All right. Well, it doesn't like when I try to use that functionality. So it's actually good finds. It might actually be helpful to just download the HTML file as opposed to printing it directly in the notebook. But yeah, if you click these, suppose you had your web browser and this HTML file was open. If you click these, they would jump directly to that section. So it looks we'll have to scroll here as I printed it directly within the notebook. So scrolling. All right. So then you can see there's also interactions, right? So these interactions actually show us a scatter plot. So you can look at different scatter plots and see if there's any relationships. So yeah, it looks like here you can see the total deal amount and valuation requested on the Y. The total deal amount is on the x-axis. And you can see that there is a correlation between those, right? You can kind of see that that positive correlation there between these two variables. There's also a heat map that shows us the magnitude of the correlation. So this is a correlation coefficient. Closer it is to 1, more positive. Closer it is to -1, more negative that correlation is. And then there's values in between, right? If it's close to 0, there's pretty much no relationship between those variables. So anything over like 0.6, 0.7 is going to be strong in absolute value. for correlation. And you can see this coefficient as well. Let's see, what did we look at earlier? Total D amount and valuation requested. If we can find those. It's a little bit harder to find. Yeah, so valuation requested and the total deal amount. So there's a couple large coefficients with valuation requested, and this total deal amount is going to be towards the bottom right. Yeah, so let me just scroll here, 0.5 or 0.858. I go back there. Yeah, there you are. Yeah, so if I look across here, valuation requested and total deal amount. So that's actually pretty positive and pretty high, right? So that's 0.858 is the correlation coefficient. Again, if it's closer to 1, that would indicate a more positive relationship. And if I look at the final bit, so I can look at also a bunch of pairs of correlations and kind of test that. But if I look at the missing values, it actually shows me per column the counts of filled in values, right? So the blue bars indicates that field is filled in, or that variable is filled in. And then these fields that are more sparse, it means that there's a lot of missing values in that field. So definitely helps me understand the missings. There's also other views for this as well, to kind of show the missingness or the completeness of each column. And finally, you can see the sample of the first 10 records and last 10 records. So again, I'm getting a lot of good insights and getting a lot of good takeaways from this report, and then also understanding kind of some initial relationships. Yeah, I would say the last thing you can look at is they have a alerts tab, and you get a lot of good alerts here, including anything that's highly correlated, anything where there's a lot of missing values, so any fields that are a lot of missing values we just looked at, and then yeah, so uniformly distributed or unique values, you can also discover here as well. So that would be the end of Module 6, and I hope that you enjoyed this demo.